In this video, we're going to be focusing on the absolute value graphs. So if you are new to the concept of absolute value, I would suggest you go and look at a video that I made with regards to the basics and the rules, basically introductions to dealing with your absolute value questions and example. So I will leave it in the description and also pin the link in the comments. So yeah, let's get on this one. So let's say you are given an example like this. You have your y, it's equals to an absolute value of x minus 1. So first thing first that I like to do is I try to look at the the parent function. So I look at the parent function in two ways. You know, the parent function for absolute value of x, you will always have a graph that looks like this. Then for this one, but we're going to interpret it as y is equals to x minus 1. So what type of graph would that be? You see this one, it's a linear graph. So if it's a linear graph, you already know from your high school experience that we can note the gradient from this. So since this is positive, it means the gradient is going to be something that looks like this. And if it was negative, it was going to be something that looks like that. I mean the shape of the graph. So we're going to still use the same methods that we used in high school and college and try to solve your x value and your y value. So you know, if you're calculating your x value, you will let your y be equals to 0. Then you will have what? Your 0 is equals to your x minus 1. Then that means your x has to be 1. Then you write that point here. Then if I'm doing my y values, then you will say your x has to be 0. Then now you'll say your y would be equals to 0 minus 1. Then your y is equals to minus 1. Then you have your minus 1. Then this is where you have that one. Then now this graph will go like that. Hence, this is why I was just saying, if it has a positive slope, it will show that it's rising. If it has a negative slope, it will show that it is going down. So now, okay, we know the graph in this form, but now they want you to write it in that form, in the form of absolute values. And as I was explaining, this is the parent function for your absolute values. So what happens each and every time you have something like this? So now you have, instead of having this absolute value of x, you have minus 1. So any value that you see that is in between here is going to be a value that is going to be making the changes along your x-axis. So rather than now having a parent function like this, you're going to first go and solve the internal part. That okay, you have your x minus 1, you basically equate it to 0, equals to 0. Then your x would be equals to 1. So since this is the parent function, it basically means now your graph is just going to shift 1 unit to the right. Then it's going to be here. Then it's going to be like this. So let me just it's going to be a graph that looks like that, you see. So here, what did we have? We still have that one, and here we will also have that one. And quick way to determine this, yeah, y and x intercept, you can still use the same method, but now remember, when we're doing with this one, we were just like using the normal route, but with this one we still need to use the absolute values, or these two cages that you see. So how are we going to go about it? We'll start by saying, okay, for the x values, what are we going to have? We'll still say we will let our y be equals to 0. Then we will have 0 is equals to the absolute value of x minus 1. You see? So this one can just be written as your x minus 1 is equals to 0. Therefore your x would be equals to 1. Hence we got it here. Then we move to the y side. You will say you're looking for your y values. Then you will say your x should be equals to 0. Then you will say you have your y is equals to an absolute value of 0 minus 1. Therefore your y would be the absolute value of minus 1, which is going to be your y is equals to, your y will be equals to 1. See? So yeah, when you are doing it in this format, you use the absolute value, then you work it going down. But if you're interpreting it like this, you just do it the normal route. So that's basically how you go about doing it. I'm not sure if they do ask you to work out the intercept, but like I just know that they're interested in you drawing the shape, or you're just checking the shape. So what do you notice between these two graphs? What you can notice is that, okay, for the portion starting from here to here, it is actually flipped to the top side. What do I mean by the top side? It was here, but it will now went somewhere along here. You see? So it means now I'm going to be erasing this one, and my new graph is going to be this one, which looks like this. So it's now like this. So what happened here was that your absolute value graph will always be above your x-axis. It can never be below. So you will never have a graph that will look like this. It always start here and go up, or it can make shifts within the x-axis, but it never goes below, which is why now if you're going to be considering your range for this one, what is your range? Your range are basically your y values. So what are your y values for this one? With the range for this one, you will say your y is greater than or equals to 0. This greater than or equals to 0, it means your 0 is included. Just include, you're going to include a restriction, so it can be your 0 going up, but that 0 it's included. It's never anything below that 0. So that would be your range. It's anything starting from 0 basically going up. So now what is your domain? Your domain is going to be what? Minus infinity to positive infinity. So your domain, these are your x values. So you see that it starts somewhere there from minus infinity, and it ends somewhere there from positive infinity. So hence we are going to be having these two ranges like this. But the most important part is that your absolute value will never produce anything that is negative. If it's anything that becomes negative, it actually flips it to the other side, so it becomes positive. Just like in the examples where I was explaining in the basics, that basically with your absolute values, you're measuring your distance, and distance will never be negative. That's one way to think about it. So we are done with the first one. I think I'm going to do 2 more examples so that you can be able to understand this concept. Remember, your first step is that you have this one. You can either do this method or just like maybe do them side by side and see what actually happens. So I broke it down into two parent function so that I could be able to just explain the concept. You know internally that you had that linear graph. Then if you solve that linear graph using the normal routes that you know, you are going to get something that looks like this. But now you move or you advance to the applied calculus method, then you would have something that looks like this. So now let me just run this one and we move to the second example. So now our second example, so now let's just say we have y is equals to your x squared minus 1. So you've seen or know the shape of this graph, and the first thing that you have to ask yourself is to ask yourself, what is this graph? Because I forgot, I was actually supposed to do it like this. Then now on this side you will say you have your y is equals to your x squared minus 1. This is where you see, okay, you are trying to draw the original, then move to the absolute, you see. So if we are always starting on this side, it means now this one, it's basically a difference of 2 squares if you're going to be factoring out or working out your values. So we know this is your y value, and if it is your y value, we're going to just write it as minus 1 here. Then if we factor this one for x's, we just have your x would be equals to plus or minus 1. As I said, it's basically the difference of 2 squares, you see. So it means you're going to be having that one, this side minus 1, then this side you have your 1. So how is it going to look like? Okay, this, it's a what? It's going to be a smiling graph, because we're checking what we're checking, the slope. The slope is positive. If it was negative, it was going to be a frowning graph. So now it means you can go and write it as something that looks like this. So yeah, that would be the graph. But now watch what happens when you come to this part. What happens when you come to this part? What do you have? You still have your minus 1 and 1. Still have your minus 1 and 1. But now remember, what did I say? I said each and every time you are drawing your graph shouldn't go below the x-axis. Whatever you have that is within the x-axis, it actually gets flipped to the top side or above your x-axis. So it's going to be flipped to the top. So instead of having this, it means now this part that you see here is going to be flipped to this side and this side. So the one that you had, these lines, they are still going to be there. It will still look like something like this, something like this. So remember, even from the first example and this example that I'm doing, even if this I was about to do it like this, it will still come as something that looks like this. So it's basically like now we just like took this one and flipped it to the other side. So you're going to be having a final graph that looks like that. So basically that's that with this example. I hope it was also clear. Then now we're going to do another example. So let me just check here. Okay, we're going to do another example. So now they give you that you should sketch the graph of your f of x is equals to an absolute value of minus 2x plus 4. So as normal, we come and write it this side, and we just like only to take the internal part of the equation, and we know this one is still a linear. And if it's a linear, what do we check again? We check the slope. The slope is negative. It means it has to be a graph that looks like this. So what else? We solve the x and y values. The x and y values, we know this 4 is going to be our y. So here we have our 4. Then how we solve our x, you know that when we say if we're solving the x values, we let the y ones be equals to 0. So just to quickly do it for the others that might have forgotten how we do it. So if I'm doing my x, we let y equals to 0. It means now you're going to have 0 is equals to your 2x plus 4 minus 2x. Then you take your 2x to this side, then it equals to 4. Then you divide by 2, divide by 2. Then now it means your x is going to be 2. So here we've worked our x is 2, our y is 4. So I'll just quickly show how I got this 4, or you can just like read it from here. So since you're working your y values, you'll come and say, where I see my x values, I'm going to let them be equals to 0. Then you see if you put 0 in here, minus 2 by multiplied by 0, that gives you 0. Then plus 4, it's going to give you this 4 that you see there. So yeah, but if you can just like read it quickly, that's fine for you. Then now it means you're going to be having a graph that looks like this. But now we have a problem. We don't want this line that is going in at the bottom. We always prefer our graph to be above the x-axis. So now what are you going to have? You're going to be having something that looks like this. Okay, you have that 2 there, you have that 4 there, so it goes like this. This part is still well, but this one now is just going to be flipped and pushed up. See, so now you're going to be having a graph that's looking like that. As easy as that. So okay, we've done with that one. So let's just do one more example. Let's look at one more example. Okay, so now let's just say you were given that you have to sketch the graph of g of x is equals to you have an absolute function minus x squared plus your 2x plus 8. And as usual, you go and write it on this side that you have your y is equals to your minus x squared plus 2x plus 8. So this part is just to help us remember how we do it, but they are more interested in this one in your test or your exam. So you still do the same thing. You go look out for your x values and you go look out for your y value. And with my y value, I said if you're looking for y values, you let your x be equals to 0. If you put 0 here and 0 here, it means you're going to be left with your 8. You see? So now it definitely mean I can go and mark that 8 here already. So now you have to factorize and find your x values. I know you guys factorize in different ways. So if you go and find the factors, you will find out you have your minus 2 and 4. So I'm going to write that minus 2 and minus 4. So we're not going to be wasting a lot of time trying to do the factorizing. So now how is this graph going to look like? We said if it's a graph that has, oh yeah, it's completely a different one. This one it's a parabola. So but now it has a negative in the middle. It means now it's going to be a frowning graph. If it had a positive, it was going to be a smiling graph. So now if it is like that, it means you're going to be drawing a graph that looks like this. So now you come to this side, which is the one that they want, and be like, okay, I do have this. As we said, our graph always has to be starting on the x-axis going up. Then what are we going to have? We still have that minus 2, and this side we have this 4, then this side we have that 8. Okay, this part is still fine. Yeah, you're gonna throw it more nicely on your side. So that part is still fine. What we just have to flip at this one. So if you flip it this one, you're just going to be getting something that's gonna go here, and this side that is going to go there. Remember, the aim is that if I'm about to flip this thing, it must land on top of this one. And even if I'm to take this one back, it's going to land exactly on this one. So you're still going to at least maybe draw something that would resemble that. So you're going to be having a final graph that looks like that. So you see how easy it is to draw your absolute value graphs if you remember your foundation that you did in high school or your college. So I'll also leave a link for the video I made on identifying your parent functions, so that you can be able to draw any graph that you come across. So if you found this video useful, please like and consider following our channel.